All right, next we'll talk about collecting and expanding, and what I'm getting at there is we're going to look at finding terms or things that are similar and combine those. That's collecting, known as collecting like terms, and the other part is expanding, and expanding is basically another way of saying multiplying things out. All right, and we'll start here. There's nothing to expand because there's no multiplication that could happen. Yes, it's true, 3 is technically multiplied by t, but there's no multiplication to do. What we're going to look for here is what can we combine? And when we go to combine stuff, it must be exactly identical. For example, if I was to put a t squared on the end of this, notice that that doesn't match t because t is technically to the power of 1. So in order to be able to combine like terms, the variable part, the letter, it has to be identical in terms of its exponent. Another thing that's important to note here is that each of these is what's called in math a term, and the term contains its sign, right? So whether it's positive or negative, and it also contains, whatever the value is. This one happens to be 4. So 3t and negative 5t both have identical variables, right? T to the power of 1. Let's combine those first. So it's 3 subtract 5, and this is where we're moving along the number line. Starting positive 3, going down by 5, we end up at negative 2, right, of value t, whatever t is, we don't know. And the other thing that can be combined, of course, that you've done a lot of already before is numbers. And we've got negative 4 and negative 6. They combine to become negative 10. And that's it. Chosen this example so we can look at something that often people aren't sure how to deal with it, and that's this right here, okay, because this is going to be an expansion as well as this. Okay, so we'll get to that in a second, but first what we're looking at is the number negative 3 needs to be multiplied by everything inside the bracket, and as we talked about in class, one way to look at this is to say that there's a silent 1 there, and we won't hate math for a second for having silent parts that sometimes appear and disappear. But anyway, there's our negative 1, and that negative 1 should get multiplied by both of the terms that are inside the brackets as well. At the end of that, we'll be able to combine the like terms. So let's start. Negative 3 of x is negative 3 of x, which is this thing that we don't know, right? X is the placeholder. And then negative 3 times positive 2 minus 6. Now, negative 1 times x is negative 1x. So here we go. We're making the 1 disappear again, right? We normally just write that as negative x, because if there wasn't 1x, there would be none of it, and we wouldn't be talking about it. More on that later. So that was the first multiplication, and now negative 1 gets multiplied by 2 as well to make negative 2. We now have a couple of like terms to combine. Negative 3 of x minus another negative 1 of x makes minus 4. And what else do we have? The minus 6 and the minus 2 combine to be minus 8. Whoops. So there we go. We've got minus 4x minus 8 as the final result. Excuse the writing. The next part of collecting and expanding, or expanding and collecting, is going to be what a lot of us know as a FOIL operation. A lot of math people really don't like that term FOIL. It stands for firsts, outsides, insides, lasts. Not sure if you could see what I was highlighting there, but we'll get back to it in a second. And the reason that a lot of people, math people, don't like this explanation is because when you have an expansion that is larger, then that concept no longer necessarily works. So let's look at what's happening here. Okay, so in terms of that thing that we said a lot of people call FOIL, and what does that mean? Well, that means, I think this is maybe a better way to look at it, that each term in the first set of brackets, so each term has to get multiplied by each term in the second set of brackets. Otherwise, you just end up with something that does not equal In other words, the numbers and letters would not match what's happening in reality. So in terms of steps, what that means is that x gets multiplied by negative 2x, then by minus 4. We follow that up where 3 gets multiplied by negative 2x and minus 4. And we've covered all our combinations, and what we've done is mathematically true according to whatever we're modeling in real life. So as we complete the operation then, x times negative 2x is minus 2x and squared, right? Because it was x times x in there. Then we have x times minus 4, which is minus 4x. Then 3 times minus 2x is minus 6x. And without running out of room here, 3 times 4, minus 12. Okay, on to the next line. What we're looking for is anything that can be combined. All right, so remembering that x squared is different than a regular x, what we see is that the only two terms with identical variables are the minus 4x and the minus 6x. So minus 2x squared stays as it is. Minus 4 combined with minus 6 goes to get us minus 10 when we're moving along the number line, and just the regular number minus 12 is at the end, and there's nothing to combine it with, so it's just going to stay where it is. At this point we're done. Some folks will maybe notice that between minus 2, minus 10, and minus 12, there actually is a common factor of either 2 or minus 2. And sure, we could take that common factor and we could break it apart, but that's kind of the opposite of what we're doing here, which is expanding. We'll do plenty of that operation, which is called factoring, later. The last example we'll look at in this section under collecting and expanding is going to involve, well, more than 2 terms in each set of bracket. This is where the FOIL acronym no longer works, because you've got something in the middle and you could add more terms. Each of these brackets could have 4, for example. I've kept the numbers reasonably, I think, simple, at least in terms of what this could be in this example, so that we can see exactly what we're doing. And we're going to follow the same concept, where the first term has to get multiplied by all 3 parts of the second set of brackets. Then the second term needs to be multiplied again by all 3, and the third term has to get multiplied by all 3. So this is a bit of a tedious question. We're just going to be doing a bunch of expanding by multiplying, and here we go. X squared times x squared is x to the power of 4. X squared times minus 2x is minus 2x cubed. We're adding the exponents when we multiply here, remember. And x squared times minus 1 is minus x squared. On to the middle term, and I'm definitely going to run out of room here. Let me go to blue so you can see what I'm following. X times x squared is going to be positive x cubed. X times minus 2x is minus 2x squared, and x times negative 1 is negative x. I will continue on the next line. I've got the colors a little confused or backwards here, so bear with me. And so this is still also the same part of the same expansion. Okay, so now we move on to the 3 and multiply it by the x squared, right? So that's going to give us plus 3x squared minus 6x, as we multiply the 3 by the minus 2, and 3 times negative 1 is negative 3. So hopefully I haven't made any mistakes, but in a tedious question like this, it's certainly possible. So I'm just going to go back and double check my work quickly. And everything looks okay, so we'll put anything together that can go together. So I look at the x to the power of 4 term first. I'm going to cross it out as I use it, so that I don't accidentally add it twice or don't leave it out. So there, x to the power of 4 is the only one that's to the power of 4, so that's that. Then we've got negative 2x cubed and plus x cubed over here, so that leaves me with negative x cubed. So those two x cubes have been dealt with. And after that, we have a negative x squared and a negative 2x squared will combine to be negative 3x squared. That takes care of all the x squareds. And oops, no it doesn't, because there was one more down there. I guess I could either do this in 2 steps, or I could continue and say that the negative 3x squared that we just came up with, right, negative 3x squared, so negative x squared, negative 2x squared made negative 3x squared, but then we're adding 3x squared, so guess what, the 3 of these come to 0 of x squared, which means we don't need to write it down. The next step is negative x and negative 6x makes negative 7x, so the x's have been dealt with, and lastly minus 3 is the last thing that's hanging around. And so that should be the result of multiplying these 2 large sets of brackets.